Who is more likely to get a medical checkup, employed or unemployed people? A team of physicians and public health specialists collected data on a sample of over 2,200 individuals. The results are in the table below. Construct a 95% confidence interval estimating the difference in the population proportions that have routine medical checkups and interpret this interval. And one question we need to start with here is, what are the populations that are being studied? There's two groups here that we're going to call population 1 and population 2. Population 1 would be employed people, and population 2 would be unemployed people. Now we want to construct a 95% confidence interval estimating the difference in the population proportions that have routine medical checkups. So I'm going to define P1 to be the population percentage of employed people who have routine medical checkups, and P2 be the population percentage of unemployed people who have routine medical checkups. I want confidence interval to estimate P1 minus P2. Of course, I could never find exactly what P1 and P2 are because I would have to collect data on all employed people and all unemployed people as far as their routine medical checkups, and that's not possible. See, I will use P1 hat minus P2 hat, my sample percentages, to estimate P1 minus P2. To calculate these sample percentages, I get the information from the table, and there were 642 out of 1,140 employed people that had routine medical checkups, and 740 out of 1,106 unemployed people that had routine medical checkups. So calculating this difference, I get 0.563, subtract 0.669, and that would be negative 0.106. So I get a negative here. That just means that the percentage of unemployed people in the sample that had routine medical checkups is greater than the percent of employed people in the sample that had routine medical checkups. So we'll have to remember to interpret the negative according to the way the sample percentages were subtracted. My confidence interval is going to be this point estimate of the difference between the population percentages, plus or minus. Remember that with percentages, we're always working with a standard normal distribution and the confidence interval splitting alpha. Now I need to get my standard deviation formula for the sampling distribution. And for confidence intervals, that is given as taking the sample percentages, multiplying them each by their complements, and dividing each of them by the sample size, taking the square root of that. And now I can put my information in here. So I would have negative 0.106 plus or minus. Now this is a 95% confidence interval and it's standard normal, so that would be 1.96 times the standard deviation, and plugging into the formula there, I have 0.563 times 1 minus 0.563 divided by 1,140 plus 0.669 times 1 minus 0.669, and then divided by that sample size, 1,106. So plugging everything into the confidence interval, I get a negative 0.106 plus or minus 0.04. So my margin of error is 0.04. So my estimate of 10.6% between the two population percentages could be as much as 4 percentage points off from what the real value is. My confidence interval then would be a negative 0.146 to a negative 0.066. Now I want to interpret that interval, giving some consideration to the negatives. And to understand those negatives, I have to remember what population 1 and population 2 are and how I was subtracting, where I'm taking the percent of employed people that have routine medical checkups, subtract the percent of unemployed people that have routine medical checkups. So the negative should be interpreted in the sense that the percentage of unemployed people that have routine medical checkups is greater than the percentage of employed people that have routine medical checkups. So the way I'm going to interpret the confidence interval, 95% confidence that the percentage of unemployed people that have routine medical checkups is 6.6% to 14.6% higher than employed people who have routine medical checkups.